The second part, bought the remaining part of your area steel with the remaining part of your area under compression. Let's talk about the first one. We have compressive force here on this area. See, we have tensile force in this steel reinforcement. Both of them equal. The compressive force, can call it C flange, equal 0.85 F prime C times B minus B web times HF. I'm sorry. What do you mean by this term? This term is this area. Yes. The total distance is B flange minus this area, or I'm sorry, this distance can give you this distance plus this distance time this thickness H flange can give you this total area, this one plus this one. So B flange minus B web, B flange minus B web equal this distance plus this distance time H flange times this thickness equal this area plus this time 0.85 F prime C can give you the compressive force. Your T flange, we can call it T flange, equal area steel flange, this part of area steel, times F yield. Both of them equal, so 0.85 F prime C B flange minus B web times H flange equal area steel flange times F yield. The only unknown in this equation is your area steel flange. You can get it. Once you get your area steel flange, your nominal moment from this part equal to area steel flange times F yield time distance between this force and this force. D minus H flange divided 2. Remember, right now I can figure out what is the value of area steel flange, and I know the original area steel. Can you calculate your area steel web?
Yes.
Yep. Area steel total equal area steel web plus area steel flange. This one is known, and this one is given in the original problem, so I can figure out what is the value of area steel web.
HF divided by 2 is
No, I'm sorry.
over here on this part.
The total thickness H flange, your location of C at mid height. So we have H flange divide 2 and H flange divide 2.
But it has to do with moment of inertia for that space, or why is it HF divided by 2?
Because your location of this force at the centroid of this area and this area. Where is the centroid? At mid height.
Okay.
Okay? Location of any force at the centroid of the area. Second part, we have compressive force C web, we have tensile force T web. In the second part, your C web equal 0.85 F prime C times A times B web. Because I don't know what is the neutral axis exactly. And T web equal your area steel web plus F yield. Both of them are equal. So 0.85 F prime C A B web equal area steel web times F yield. The only unknown in this equation, your distance A. I can find A. Once you found A, your nominal moment, second part, equal this T, which is area steel web times F yield, times this distance, which equal D minus A divided 2. Why D minus A divided 2? Because the location of this force at the centroid of this area, which is A divide 2 and A divide 2. So the distance between this point and this point equal depth minus A divide 2. Once you get the nominal moment from the second part, your final nominal moment for the whole cross section equal first nominal moment plus second nominal moment. You can add phi for this part, for this nominal moment to get your design moment.
I have one more question. When we do our initial test to determine that the neutral axis is outside of the flange, isn't that the same A, or do we have to solve for a different A?
Yeah, we will get another A. So your question, the first question, it's not correct 100% because you based the original value of A based on assumption, and this assumption not correct. The new A will be completely different than the first one. So if your neutral axis in between at the edge of the flange, so we can expect within the flange or outside the flange. So it's critical. This situation is very critical. Okay. Yeah, go ahead.
For the design moment for M nominal, do we multiply each of those, each flange in the web by 0.9?
No, add them together.
Then
The
multiply.
sum multiply by 0.9 to get your design moment. Let's do an example and see what's going on. Sometimes you will say, hey, design of concrete, we have many cases. It's hard. But I like the way that Chris solved in the steel exam. He construct sheet Excel. If you construct sheet Excel, it will take some time at the beginning. But after this, you can repeat infinite number of problems. I think you can set up sheet Excel for these calculations. Once you are done for the first time, then you can change your parameters, that's all. And I think if you go to some website like ACI or whatever, you can download design sheet Excels. All of these sheet Excels based on all of these calculations. If you are good in Excel, you can set up these calculations, this step in Excel. Just put your area steel, put your depth, your flange width, and the Excel sheet will give you the final design moment. Okay. Actually, we just solved this problem and we assumed your neutral axis within the plane and your assumption was wrong. Second step, hey, neutral axis will be within the web or outside your flange. So we have something like this. That's right. Your cross section as a total cross section can be divided into two parts. First part of your area steel called area steel flange with this part plus this part only. So we have two parts. This one plus this one. Plus the remaining area steel, we talk only one part. The remaining part, which called area steel web with the remaining area of concrete under compression. This distance will be E. A little bit behind your neutral axis. Anyway, let's start with the first part. We have tensile force called T flange. We have compressive force called C flange. C flange equal T flange. What is the value of C flange? 0.85 F prime C time, what's this area?
B minus.
Okay, if you cannot figure out, go back. What's this area plus this area? Anyway, the total distance 30 minus 14 can give you what this distance is plus what this distance is. So 13 minus 14 equal 16. 16 times 4 can give you this area. Just only 0.85 F prime C time area for this part plus this part equal T flange. I don't know what is the area steel flange, but I know what is the value of area if yield 60,000. Please put your F prime C 4,000. The only unknown in this equation is your area steel flange. What is the value of your area steel flange?
3.63.
3.63 inch square. So this area steel flange equal 3.63. Your nominal moment from this part number 1 equal this force times this distance. This force T flange times this distance equal D minus H flange divide 2, because this distance H flange. D minus H flange divide 2. T flange equal 3.63 times F yield 60,000. Your depth 30 minus 4 divide 2. You can figure out what is the value of the first nominal moment for the first part. For the second part, anybody can tell me what is the area steel web? Yeah, area steel web for this part plus area steel flange for this part equals the original area steel. From the first part, you can figure out what is the area steel flange, 3.63. So I can figure out what is the value of area steel web. What is the value?
649. 6.49.
6.49 inches square. So this area steel 6.49 inches square. Go ahead, do the same. We have here tensile force called T web. We have force here, compressive force here called C web. For the second part, C web equal T web. So 0.85 F prime C time this area. This area equal P web time A. P web time A. Equal area steel web type F yield. Put your number F prime C 4,000, B web 14 time A, I don't know. Area steel web 6.49 times 60,000. The only unknown here is your distance A. What is the value of distance A?
.19.
8.2 inch. Then your nominal moment from the second part equal this force as a T-web times this distance, D minus A divided 2. So area steel web times F yield times D minus A divided 2. Your value will be 6.49 times 60,000. Your depth 30 minus A divide 2, you can get your number. Your nominal moment total equal nominal moment 1 plus nominal moment 2, you can get your final nominal moment. Your design nominal moment, your design moment will be this number time 0.9. I am done. Remember, at the end, your moment from structure analysis results must be smaller than or equal your design moment for your beam. So we have two parts. First part, we need to do structure analysis. You have a beam, maybe with uniform distributed load, concentrated moment, whatever. And you draw your bending moment diagram. What is the final, the maximum moment, which called M output, based on 1.2 dead load, 1.4, 1.6 live load, and you get your final maximum moment. This moment from